In step 1, we find the derivative of the function f. So I'm going to write f prime of x, which is the derivative of f of x. And this equals, we should find the derivative of each terms on the right side expression. So the derivative of 4x cube is, we put the 4, and then derivative of x cube is 3x squared using the power rule, minus, we put the constant 6, and derivative of x squared is 2x. Then I put this negative 72. Derivative of x is 1. Then the derivative of 2, which is constant, is 0. So we ignore it. Let's simplify this. So we get f prime of x, and this equals 4 times 3 is 12, and 12 times x squared is 12x squared, minus 6 times 2 is negative 12, and this becomes negative 12x minus 72. And so this is the derivative function f prime of x of f of x, that is 12x squared minus 12x minus 72. Now let's do step 2. Here we should find the critical numbers by solving f prime of x equals 0. So I'm going to replace f prime of x equals 0 in this expression. So therefore this becomes 0 equals 12x squared minus 12x minus 72. I'm going to divide all the terms by 12 because I see a factor of 12. So therefore this becomes 0 by 12 is 0, and this is x squared minus x minus 72 by 12 is 6. So it's a quadratic equation which we can solve for x. So I write this in terms of product of linear factors, that is x minus 3 times x plus 2, because negative 3 times positive 2, this equals negative 6, and this is the product, and negative 3 plus 2, and this equals negative sum. So this is the sum, which is negative 1. So this factorization is perfect. Now we can solve for x from this equation, that is x minus 3 equals 0, or x plus 2 equals 0. So we see that x equals 3, and x equals minus 2. So these are the critical points of the function. Okay, so now that we have completed the step 2, that is, we have determined the critical points, we can move on to the step 3, and here we have to determine the function values at the critical points as well as at the endpoints. So first, let's determine this f of minus 2, and this can be found by replacing x in f of x by negative 2. So let's do that. So therefore, I'm going to replace x in f of x. So replace all x by negative 2. So therefore this becomes 4 times of negative 2 quantity cube minus 6 times of negative 2 quantity square minus 72 times of negative 2 plus 2. So we get 4 times of negative 2. Negative 2 quantity cube is negative 8. Negative 8 times 4 is negative 32. And this is negative 2 quantity square is 4. 4 times of negative 6 is negative 24. And here we have negative 72 times negative 2, which is positive 144 plus 2. And when we simplify this, we get positive 90. So this is f of minus 2. Now let's find f of 3. So once again, we have to replace x by 3 in f of x. So when we do that, we get 4 times of 3 quantity cube minus 6 times of 3 squared minus 72 times of 3 plus 2. So this gives 3 cube is 27 times 4 equals 108 minus 3 square is 9. 9 times 6 is 54, minus 72 times 3 equals 216 plus 2. And so when we simplify this, we get negative 160. And so this is f of 3. Now let's find f of negative 3. Replace x by negative 3 in f of x. So it is 4 times of negative 3 quantity cube minus 6 times of negative 3 quantity square minus 72 times of negative 3 plus 2. And so this equals negative 108, because negative 3 quantity cube is negative 27, and when you multiply with 4 we get negative 108. And here it is once again negative 54, because negative 3 quantity square is 9. 9 times negative 6 is negative 54, and this will be 72 times, that is negative 72 times negative 3 is positive 216 plus 2. And so when we simplify this, we get 56. Therefore, 56 is f of minus 3. Now let's find f of 4. So replace x by 4. Therefore, this becomes 4 times of 4 cube minus 6 times of 4 squared minus 72 times of 4 plus 2. And so this gives 4 cube is 64. 64 times 4 is 256 minus 4 square is 16. 16 multiplied by 6 is 96. So we have negative 96 minus 72 times 4 equals 208. So it is negative 208 plus 2. And when we simplify this, we get negative 126. So negative 126 is f of 4. Okay, so we have now determined the function values at the critical points as well as at the end points. We should find the maximum and minimum out of these values. Clearly, 90 is the maximum, and the minimum value is negative 160. So therefore, we see that absolute maximum of f of x is positive 90, and absolute minimum of the function f of x is negative 160.